Greetings, welcome to this new video about Supermesh analysis. Solve the problem number 2. Let's consider this network consisting of 4 resistors labeled R1 through R4, as well as one voltage source V1 and 2 current sources IA and IB. The question now is to calculate the dissipated power in each resistor. Let's move on to the solution. First, let's begin by defining the number of meshes in this network. It's evident that there are 3 meshes: mesh number 1, mesh number 2, and mesh number 3. Now let's proceed to assign the mesh currents in this network, and I will consider I1 is the current in mesh 1, I2 is the current in mesh 2, and I3 is the current in mesh 3. We can see that all the currents are chosen in the clockwise direction. After we finish the assignment of the mesh currents, we need to remove the branch containing the current source IA. Then we obtain our super mesh. Let's start first by applying KVL in the super mesh. We can write negative V1 plus R1 I1 plus R2 I2 plus R3 I2 minus I3 is equal to 0. By replacing the voltage and the resistors with their numerical values, we obtain negative 5 plus 5 I1 plus 3i2 plus 2i2 minus i3 is equal to 0. If we continue simplifying this equation, we obtain negative 5 plus 5i1 plus 5i2 minus 2i3 is equal to 0. And I will call this equation number 1. Let's move on now to mesh 3. By applying KVL in mesh 3, we can write I3 is equal to negative IB is equal to negative 1 amps. We currently have 2 equations with the 3 unknowns, which means we require one additional equation to solve this problem. In order to get this equation, let's focus on the current source IA. In the current source IA, we can write IA is equal to I2 minus I1. That means I2 minus I1 is equal to 2. Then we obtain now 3 equations. We only need to solve these equations to find the values of the currents I1, I2, and I3. Let's start first with equation 1 plus 5 multiplying equation 3. Then we obtain negative 5 plus 5i1 plus 5i2 minus 2i3 plus 5i2 minus 5i1 is equal to 10. We have here 5i1 and negative 5i1, they cancel each other. Then we obtain finally 10i2 minus 2i3 is equal to 15. That means I2 is equal to 15 plus 2i3 over 10. By replacing the value of I3 here, we already have I3 is equal to negative 1. We obtain I2 is equal to 1.3 amps. From equation 3, we have I1 is equal to I2 minus 2. That means I1 is equal to negative 0.7 amps. After we found the currents I1, I2, and I3, we can now calculate the dissipated power in each resistor. Let's start first with the dissipated power in the resistor R1 is equal to R1 I1 squared. R1 is 5 ohms and I1 is equal to negative 0.7 amps. Then we obtain 2.45 watt. The dissipated power in the resistor R2 is equal to R2 I2 squared we get 3, multiplying by 1.3 square, we get 5.07 watt. Let's move on to the dissipated power in the resistor R3 is equal to R3 I2 minus I3 square, we get 1058 watt. And the last one, the dissipated power in the resistor R4 is equal to R4 IB square is equal to 5 watt. After completing the calculation, we conduct the simulation using SPICE to verify our results. Now let's proceed to the SPICE environment. Here is the circuits done by SPICE simulator. We can see here this is our voltage source V1, our current source IA 2 amps, IB 1 amps, and resistors R1, R2, R3 and R4. And I connect here a wattmeter to measure the dissipated power in the resistor R1, another wattmeter to measure the dissipated power in the resistor R2, and another wattmeter to measure the dissipated power in N3, and the last one to measure the dissipated power in R4. Let's go to analysis, DC analysis, calculate nodal voltages, and we can see here this is our result obtained by calculation. P1 is equal to 0.45 is the same here. P2 is equal to 507 is exactly the same here. P3 is 10.58 is the same here, and the last one is P4 is equal to 5 watt is the same here. The results obtained by calculation is similar to the results obtained by simulation. Thank you for watching this video. If you have any question, do not hesitate to contact me by email or leave a comment under this video, and I will answer you as soon as possible. If you like this video, don't forget to subscribe and share. Have a nice day. Bye bye.